Well, so we will further continue our applications of electrical forces and other applications to the questions. Now here, in this question, I will write a statement, and for that statement, we have to mention the right answer. Our statement is force experienced by a test charge. Force experienced by a test charge. I have written Q naught. By a test charge of 1 stat Coulomb. Force experienced by test charge of 1 stat Coulomb in magnetic field of 1 Tesla. Force experienced by test charge of 1 stat Coulomb in magnetic field of 1 Tesla. When source charge is moving with velocity of 1 meter per second will be now first option. I will give now the 4 options for this statement. The first option is 3.3 10 to the power 12 newtons. The second option 3.3 10 to the power minus 9 newtons. Third option 3.3 10 to the power minus 10 newtons. And the fourth option 3.3 10 to the power minus 12 newtons. Now, first of all, the question is given in the form of symbolic representations. You will remember, when we write Q naught, this is called test charge. Test charge. And when we write Q, this is called source charge. And when we write B, this is called magnetic field. Magnetic field. So these are the symbols we are using here. Q naught, test charge, Q, source charge, V, magnetic. You will always remember that whenever we take electric field and we put some charge in the electric field, like for example, well, so here I have drawn electric field. This is the electric field. And you remember that electric field is given by composition F over Q naught. This is the formula. And when we write F is equal to EQ naught, then we have to interpret this formula E is electric field. This electric field is generated by Q. So you remember Q is the source charge. The function of the source charge is to generate electric field. And also you remember that this source charge is static, not moving, at rest. So Q is the source charge, this is static, and around this charge the field developed is E. Now what this electric field will do? Electric field will exert force. So source charge give rise to electric field. Electric field will exert force, and force will be experienced by test charge. So what's the difference between test charge and source charge? The source charge has tendency to generate field. Test charge also has tendency to generate field, but the field is so small that is insignificant, not significant. So you will remember that for test charge, electric field is delta E. When we write delta E means very small electric field. And this small electric field is approaching zero. Approaching zero, not exactly zero. So you will remember, E is the electric field generated by source charge. Source charge is that charge whose field is E, and this field is very large. I have written two arrows. I am using symbols here. So when we write two symbols like this, it means field is very large. So this charge is giving rise to field, and field is exerting force, and force is experienced by test charge. So the point to remember, test charges have no field of their own. Even if their field is there, negligibly small. So it is not interfering. Source charge is that which has significant field, and its tendency is to generate electric field. Electric field will exert force, and force will be experienced by test charge. So now you will always remember, force due to electric field is EQ naught. Now another thing, I am writing another formula, F is equal to B Q naught V sine alpha. Now here, B stands for magnetic field. B stands for magnetic field. And it is generated by moving charge. So what is clear to you? Moving charges give rise to two types of fields, electric field as well as magnetic field. And both the fields, they will exert force. They will exert force on the charge. That is, force is exerted on Q naught. It means that if this is magnetic field, like this, if this is magnetic field, in magnetic field this is the source charge, test charge, Q naught, and the value of the magnetic field is B, then this B will exert force here. That force is B Q naught V sine alpha. So you will now remember, magnetic field is B, it will exert force. Force is experienced by this test charge. V is the velocity of moving source charge. Velocity of moving source charge. And alpha is the angle. This is the angle between magnetic field and the source charge. So you will remember, if angle is not specified, the angle is taken as 90 degrees. And sine 90 will be 1. Sine alpha means sine 90, and that is equal to 1. So now you will remember in our question, two things are clear. Force due to electric field, force due to magnetic field. Q naught is the test charge experiencing force. It has no field of its own and it cannot exert any force. The force will be negligible. Other thing, magnetic field, that is B exerting force, and this force will be how much? B Q naught V sine alpha. Q naught is the test charge, force will be exerted on the test charge, and V is the velocity of moving source charge. V is the velocity. And alpha is the angle of inclination. If more elaborately you wanted to understand, it is like this. These are the three-dimensional diagram. OX, OY, OZ. This is electric field, magnetic field, and this is the motion of charge. This is a three-dimensional figure, this is 90 degrees. Like length of the room, the breadth of the room, and the height of the room. So this is x-axis and y-axis, and third axis is drawn like this, out of the plane. So that will be 90 degrees. I will put like this angle 90, this angle 90. So it appears as if it is not 90, but it is taken as 90 because this line is not the actual line. The line is like this. And sine 90 is how much? 1. This angle is supposed to be alpha. So now you will remember that here force due to magnetic field is this one. To solve this question, see, so many things are involved. If all the things are known to us, then only the question can be done. Otherwise the question cannot be done. And if sine alpha is sine 90, then we can write like this. B is equal to F over Q naught V. We have taken alpha as length. That is, magnetic field is force over Q naught into V. Magnetic field must be taken in Tesla or Weber per meter square. Force must be taken in newtons. Test charge, coulombs. Velocity, meter per second. And you will further remember 1 Tesla 10 to the power 4 Gauss. Gauss is CGS unit of magnetic field. Tesla is MKS unit of magnetic field. 1 Tesla 10 to the power 4 Gauss or 1 Gauss. 10 to the power minus 4 Tesla. Gauss is CGS unit. CGS, unit of magnetic field. Tesla, MKS unit of magnetic field. So now this is the formula of magnetic field, this is the formula of electric field. These two formulas. These formulas must be remembered to solve it. Q naught is the test charge, Q is the source charge, V is the magnetic field. To understand the angle, this x-axis indicating electric field, y-axis indicating magnetic field, and the third axis, that is the z-axis, which is imaginary. The line is like this. Because this line cannot be drawn, so we take the projection of the line. So alpha is 90 degrees. Sine 90 will be how much? 1. So we have taken V as F by Q naught into V. Our question was force experienced by Q naught, test charge, of 1 stat coulomb. Now what is 1 stat coulomb? 1 stat coulomb means 1 ESU of charge. And 1 ESU of charge is how much? I have already explained to you the value of 1 ESU in terms of Coulomb. So 1 Coulomb is 3 into 10 to the power 9, and 1 ESU of charge has an order of how much? This is 1 Coulomb. 3 into 10 to the power 9 ESU, and 1 ESU, that is 1 over 3 10 to the power minus 9. So it is generally taken as 3 into 10 to the power minus 10 Coulomb, approximately. So here 1 ESU is this much, 1 stat Coulomb. So what is the value of 1 stat Coulomb? This one. And Q is moving charge, speed is this one. Magnetic field is 1 Tesla. Now apply this formula. Because our question is force experienced by test charge of 1 stat Coulomb, this many coulombs. So for B, we will put 1 Tesla. So it is 1. Test charge, we will put 3 into 10 to the power minus 10. For V, velocity, we will put 1 meter per second. So multiply all the numbers. 3 into 10 to the power minus 10 newtons. Is there any option of this pattern? This is the nearest option. 3.3 10 to the power minus 10 newtons. If you take it exactly, it should be 3.3 10 to the power minus 10. So I hope this calculation is clear to you. So this is how we have applied, that is the force experienced by test charge. Thank you very much.
इलेक्ट्रिक चार्ज से कुछ नहीं होगा? इलेक्ट्रिकल फील्ड का?
It will not be applied. इलेक्ट्रिक फील्ड है ही नहीं यहाँ पर. सवाल में मैग्नेटिक फील्ड दी हुई है.